So we are now at improper integrals. So if the range of integration is not finite, or if f is not defined or not bounded at one point or more points at a certain interval, then the integral of f over this range is what we call an improper integral. Now, improper integrals have the form 0 to infinity f of x dx, which is the upper limit is not finite. You also have minus infinity to b f of x dx, where the lower limit is not finite. And for the third case, we have minus infinity to infinity f of x dx, wherein the lower limit and the upper limit is not finite. Also, there is a case wherein we integrate a b f of x dx, wherein there exists c element of the interval that is not defined on f, which is not defined on f. To evaluate such improper integrals, for example, for this case, a infinity f of x dx, we can write this as limit b approaches to infinity of the integral from a to b f of x dx. So notice that this expression is simply the definite integral. Now, by taking the limit as b approaches to infinity, we get this expression. Similarly, so minus infinity to b f of x dx, we can evaluate this using this expression. And finally, for this expression, so we can introduce a point c wherein c belongs to the interval. So we can evaluate this as minus infinity to c f of x dx plus c to infinity f of x dx. So where c belongs to a certain interval. So these are the examples of improper integrals that we are going to do. So we will start at the Laplace transform. So our definition of the Laplace transform, we have f of s, which is also equal to L of some function f. So that is the integral from 0 to infinity of e to the minus s x f of x dx, where s be greater than 0. So, for example, Let's find L of A, where A be constant. So here f of x is A. So by doing the definition of the Laplace transform, we have f of s, or L of A. So we have 0 to infinity of e to the minus sx times a dx, and then we isolate a. Now to integrate this, we will use some substitution method. So we let u be minus sx, du be minus x dx. So minus 1 over s du is dx. So we have minus a over s integral from 0 to infinity of e to the negative e to the u du. So we will have minus a over s e to the negative s x. So evaluated at 0 to infinity. So minus a over s. So we have the limit b approaches to infinity of e to the negative sb. So we have minus e to the negative s times 0. So minus a over s. The limit of e to the negative sb as b approaches to infinity is 0, then minus, so this is 1. So negative times negative is positive. So the final answer would be a over s. So next comes the gamma function. So the gamma function is of the form 0 to infinity x raised to n minus 1 e to the negative x dx. So the notation for the gamma function, we have this, and we read this as gamma of n. So let's have an example. So find, let's say, gamma of 1. So to do that, we apply the definition of the gamma function. So x to the 1 minus 1 e to the minus x dx. So this gives you 1. So we only have integral from 0 to infinity of e to the negative x dx, which is e to the negative x evaluated from 0 to infinity. So we will have 1. So we have some remarks about the gamma function. So the gamma of n plus 1 is equal to n times the gamma of n. The gamma of n plus 1 is equal to n factorial, where n element of the positive integers, and the gamma of 1/2 is equal to square root of pi. We also have the beta function. So the beta function, we have the notation b mn. So we have integral from 0 to 1 of x to the m minus 1 1 minus x to the n minus 1 dx, where m and n be greater than 0. So we have a remark here regarding the beta function. We can evaluate the beta function using the gamma function by this equation. So the beta of mn is equal to the gamma of m times the gamma of n divided by the gamma of m plus n. Okay, so we also have convergence and divergence in improper integrals. Now, we say that this integral, so a to infinity f of x dx, is convergent if this limit exists. Otherwise, this integral is said to be divergent. So similar argument for the integrals, integral of minus infinity to b f of x dx and minus infinity to infinity f of x dx. So it is said to be convergent if their limits exist, and then otherwise they are divergent.